video. Okay, so how do we know whether a number is a prime number or a composite number? So a prime number, when you divide it, it only has two factors, 1 and itself. A composite number has more than 2 numbers. So an example of that is the number 2. Can you divide 2 by anything other than 1 in itself? No. How about 3? Does 1 go into 3? Yes. Does 2 go into 3? No. Does 3 go into 3? Yes. So this is a prime number because when you divide it by different numbers, it only has 2 factors. This is a prime number as well. Let's check number 4. So the number 4, does 1 divide into it evenly? Yes. Does 2 divide into it evenly? Yes. Does 3 divide into it evenly? No. Does 4 divide into it evenly? Yes. So this is an example of a composite number because it has more than 2 factors. Let's check number 5. Does 1 go into it? Yes. Does 2 go into it? No. Does 3 go into it? Nope. Does 4 go into it? Nope. Does 5 go into it? Yes. So 5 is a prime number. Let's try 6. Does 1 go into it? Yes. Does 2 go into it? Yes. Does 3 go into it? Yes. Does 4 go into it? No. Does 5 go into it? No. Does 6 go into it? Yes. So this is a composite number. So guys, can you unmute yourself, please? So Cade, I want you to find the factors of 9, and Lila, I want you to find the factors of 11. You're going to do exactly what I did.
I got it, I think.
All right, what did you get, Cade?
9, 1, and 3.
Lila, what did you get for 11?
I'm kind of still working on it.
Okay. So all we have to do is say, does 1 go into it? Does 2 go into it? 2 times something equals 11? No. 3 times something equals 11? No. 4 times something equals 11? No. 5 times something equals 11? No. And then we only have to go to the halfway point. So we're going to say, does 6 go into it? No. Now we close it off with 11. Does that make sense to you guys?
Yeah.
Okay, let's do, Lila, you do 12, Cade, you do 14. So you're going to do the same thing. Does 1 go into it? Does 2 go into it? Does 3 go into it?
I finished.
Okay. What did you get, darling?
1, 2 in itself.
Check some more numbers.
Wait.
You might have missed some.
I got 1, 2, 10, 3, 4, 6, and 12.
Okay, tell me the 10. 10 times what is 14?
Oh, I thought I was doing 12.
Oh, you did 12. Okay. So you did 1, 2, 4, 10, 6, and 12. Okay. So tell me what the 10 is. 10 times what equals 12? It's fine. So we just cross it out. So we check them all by saying, did I get all the factors? Do you guys remember I did a rainbow? I showed you that each of these would always have a match. So 4 doesn't have a match. I think you did say 3 though. So then we would do our match here. They always have to have a match. The only exception is when it's a double, like 3 times 3. Does that make sense to you guys?
Okay.
So like 16, we would do, does 1 go into it? Yes. Does 2 go into it? Yes. Does 3 go into it? No. Does 4 go into it? Yes. Does 5? No. 6? No. 7? No. 8? Yes. 9. We're at the halfway point, so now we can close it off. Now we check for matches. 1 times 16 is 16. 2 times 8 is 16. And then 4 doesn't have a match, but we know 4 times 4 is 16. So I always just make a match with itself by just doing this. If you don't have a match, that means you're missing one of the factors. So suppose when I did 16, I got this, and then I went to go do my rainbow. Oh, look, I'm missing this factor. It's not matched with anything. So then I would say 2 times what equals 16, and then I'd squeeze my 8 in there. Does that make sense now?
Yeah.
Okay, awesome. To do a prime factorization tree, we're going to do, you write the number there, and then you find 2 factors that go into 8. You can pick any 2 factors that if you multiplied them together would equal 8. So, Lila, what are 2 numbers that when you multiply them together would equal 8?
2 and 4.
Yeah. Cade, what 2 factors when you multiply them together would equal 4?
1 and 4.
But we can never use 1 and
4, 2 and 4.
2 and 2.
2 and 1.
2 and 2.
2, yeah, 2 and 2.
And then can 2 go any lower? No, right? Because the only factors it has is 1 in itself, which means it's a prime number, right? So now when it becomes a prime number, you circle it. And that tells the teacher or whoever's correcting your paper, and it also tells you that you cannot go any lower. So for a prime factorization tree, the first step is to find all the factors until there's only prime numbers left. And then you circle them. So step 1 is to find them. Step 2 is to circle all the prime numbers. And then step 3 is to write them all out. And we put a multiplication in between them. And for prime numbers, we use this as our multiplication sign instead of a times, like an X. So you're going to go 2, a dot in the middle, 2, and a dot, and a 2. Now we check, is 2 times 2 times 2 8? Well, I know 2 times 2 is 4, and 4 times 2 is 8. So am I correct?
Yes.
Yes, so this has to match your original number that you've worked with. Let's try a little bit of a harder one. So we're going to do 80. Cade, what are 2 factors that go into 80?
40 and 40.
40 and 2. You're multiplying?
Oh, but that is plus.
40 and times 2. All right, Lila, we're going to circle this because it's a prime number. What are 2 numbers that go into 40?
Just go into?
Yeah, something times something equals 40. You can use...
Times something. times 2?
Yeah. You can use 20 times 2. You can use 8 times 5, right? 8 times 5. 10 times 4. You can use any number you want, but 20 times 2 is beautiful. Now, we circle this because it's a prime number. And then Cade, what is a factor times a factor that would equal 20?
2 times 10.
Mm-hmm. You can use 4 times 5 as well. Anything. So now we circle this 2. Lila, well, bring it home for us, girl. What are 2 numbers that when you multiply them together equal 10?
5 and 2.
Yep. And 5 is a prime number and 2 is a prime number, so we circle it.
I have a question.
Yeah.
Why is there's only 1, 2, there's all 2's in this?
Yeah, it just depends. So you just keep going lower and lower, and sometimes it's a 2, sometimes it's 3. It could be any number that's a prime number. So just for this example, you're right. There's a ton of 2's. So we're going to collect all the circled numbers. 2 times 2 times 2. And I just crossed them out to make sure that I got them all and I didn't miss one. Times 5. And we always put them in order from least to greatest. So we would do 2 times 2 times 2 times 2 times 5. And then now I'm going to check my answer. 2 times 2 is 4. Times 2 is 8. Times 2 is 16. And then 16 times 5. If that equals 80, we did it correct. If it does not equal 80, we have done something wrong. So we got it correct. Does that make sense? All right, we're going to try a trickier one.
What's trickier?
Trickier means that it's maybe not going to appear to you right away. 64. So you guys can do that separately, and then we will talk about it when you are done. And I'm going to stop the video.